Hey guys, very good evening. This is Yogen from Forsk School. Uh, can you please confirm if you can hear me, guys? Maybe you can use yes and no button, or maybe you can raise your hand. Better you use yes and no button. Yeah, okay, cool. Thank you. So, guys, this is our day one, and this day one program is basically like obviously this program is on deep learning. So what is the agenda for today? Today we are going to learn some of the basics uh, in deep learning, right? And uh, as you can see my screen, guys, I have been using an editor, right? So can you see that, guys? Can you see? Yeah, okay. Kunal saying yes, sir. Yeah. So guys, if I talk about that, what we are going to do in next couple of days, right? So today is day one, that is our Monday. So today we'll talk about deep learning basics. On the day two, I will talk about that how you can create a artificial neural network using a library called Keras. So Keras is an open source library from Google, so we would be using it. And obviously, what is ANN? As of now, I'm sure that most of people don't know, but that's not an issue. I will explain each and every aspect of what the ANN is, and then I will use that ANN to solve some problem. On the day three, guys, right? On the day three, we'll talk about a very important feature in deep learning, and that deep learning basically in most of the cases is now revolving around computer vision, right? Object detection, face recognition, driverless cars are using that feature, uh, you know uh, and then Tesla is building driverless cars, or Google is working on that, and other companies are also trying to use computer vision. So for computer vision, guys, there is a specific concept or architecture in deep learning that is called as CNN, convolutional neural network, and we will also build a CNN and we'll try to solve a problem. So obviously Keras would still be there, and that would be the case, and that would be the part one, guys, because this is going to be really important discussion. So we'll understand CNN concepts in two parts. On day three we'll cover the part one, and on the day four, guys, we'll talk about CNN, uh, and how you can use CNN to let's say identify some object in the image and all. So all of that would be practical. All of that would be practical. So it would be a part two, guys. That would be the part two. On day five, we'll talk about uh, on day five we'll talk about RNN. And RNN stands for recurrent neural network, and sometimes people RNN use RNN for time series analysis, right? Time series analysis. For today's class, you don't need anything, guys. I'm just going to give you a background around deep learning, I will, give you a demo that what tool we are going to use for our practical, part of the sessions. So that is there. So you don't have to, use anything as of now. Just focus on what I say and what you see on the screen. So that is there. And on the day 5, guys, day 5 is done, and then on the day 6 we'll talk about a couple of more practical oriented use cases in deep learning. So use cases in deep learning, that how, let's say various companies or how various organizations are using deep learning, and what you can do around that, and what kind of projects you can make, what are the next step, that after learning so much from here, what you can do if you are interested to continue your deep learning journey. So that is there. For the people who are who are the first timers at the Forsk, people who have not joined any course in the past from Forsk, I will explain couple of things for them, guys. Every day we are going to have a class from 4 p.m. onwards. So class would be starting at 4 p.m. only, and it will go up to 6 p.m. Generally, uh, you know, first 1.5 hour, is for demo and discussions, guys, and later, 30 minutes are for doubt session. So you can call it as a doubt session, or you can call it as a question answer session, or anything else. But that's there, where you can ask any queries, and we'll try to answer those questions. Uh, Guys, we are recording this session. This session is also available and on YouTube. This is actually live on the YouTube right now. So this would be available on our YouTube channel. So you don't have to record at your end. This would be uploaded. So sessions would be uh, based. Uh, so I can see, like, sessions would be recorded and available on YouTube. So guys, you can go to YouTube, and there is a channel called Forsk Coding School. You can go to this channel and subscribe to it, and you will see the notifications related to the new videos that we upload every day. Generally, uploaded videos are immediately available because the session is live. Otherwise, it takes 1 hour or so after closing the session, and after that you can have you can see it, or you can watch it on the YouTube. So this is kind of you know this, and uh, there are a lot of people in the session who have recently completed our a Python program, or a machine learning and AI program with Python. So I'm assuming there are a lot of people here, and they are excited to start their journey on the deep learning as well. So this is that, guys. And again, one more announcement, guys. This is obviously entirely a free program, free program to join and free program to audit. There is uh, no charges in joining and accessing the content, and attending the classes, attending the sessions. But if you want a certificate of this program, obviously it's a paid. And Dr. Sylvester, if you can hear me, uh, uh, we'll open the registrations for the certificate later on. We are not opening the registration process for certificates. Dr. Sylvester, can you let us know that what is the pricing for certificates and deep learning?
It's 500 rupees, sir.
Okay, so guys, the session is free to join, and if you pay 500 rupees, you know, uh, for the certificates will be issued to you. So that's there. and we will, registrations for these will start later, not today, right? Registrations will start later. That's there. So now there is a comment from Siddharth Gupta. Siddharth is saying, so why you are not using a sketchbook? Siddharth, today I have, power down in my locality. There is no power. So I want to save power, because if you attach, additional devices to the system, it will, consume more power. So I'm just trying to save that power, right? That would be there. And Sangeeta, it would be a certificate of completion. It would be a certificate of completion on, a deep learning program, right? A certificate of internship is given when you join our, project seasons. Project seasons are different, and these courses are different. In the project season, what we do, guys, in the project season, you develop a live project. You develop a real life project where client has given some problem to us. And what happens generally, that project season is a 4 weeks long program. In the first week or so, you are given training so that you can start working on the development cycle. And after completion of the training, you start on the development cycle. So there is a development that goes around 2 weeks. And then, guys, there is last week, which is used for, this is, last week, where it is used for documentation and, updating your GitHub and all. And project season 3 is starting today. It will start at 9 p.m. today. And I think a lot of people have already, registered for that. And generally that's a 1 month process, and you get a letter of internship in that case. So that is there. Vishesh, you can do that. Yeah, Vishesh, you can do that, right? So Rihan, there is no procedure. You have to register for that. And Dr. Sylvester, maybe you can do one thing. Can you please share the link for our project season as well?
Yeah, it's starting today itself. Today in the evening 9 o'clock.
Yeah, it's starting in the nine. But can you? Okay. Do you have some Zoom link details? If you have, you can share that with them, so probably, and they can join. So guys, that project season is starting on 9 p.m. today evening. So let me start with guys, some of the basics around deep learning and all. So now let's focus, right, on this. So first of all, guys, we have to understand a couple of terms. The couple of terms are like what the AI is, what the ML is, and what the DL is, right? So AI stands for, uh, artificial, intelligence. That is there. Machine learning means, ML means machine learning. And, DL stands for deep learning. And now, guys, how you define AI, right? How you define AI? Any machine, right? Any machine which behaves like human, right? Any machine which behaves like human is AI machine. So basically that machine is trying to replicate the human behavior. But as a human, we do lots of activities, 24/7. But that machine would be specifically doing 1 or 2 tasks, right, which are similar to human behavior. So it cannot be a generalized AI, We call this as a narrow AI. Why we are calling it as a narrow AI? Because obviously it is, replicating, it is mimic the human behavior, but not, entire, full activities of the human. This machine is going to perform one or two tasks only, right? So maybe, it can drive the car automatically. Maybe, it can, does it can do packaging and, all those things in the warehouse. Robots are there, that is there. And uh, this is AI. And now question comes that how to achieve AI, how to achieve AI. So to achieve AI, guys, to achieve AI, that how you can also make your AI machine, right? How you can also make your AI machine, guys. For that, you can use machine learning. You can use machine learning. And uh, in machine learning, guys, the machine, actually learns from the experience. It actually learns from the experience. It learns from the data, right? And it learns from the data. And in machine learning, we do not explicitly program the machine. We do not give instructions, right? Rather than instructions, we give the machine the data, and it understands the data, and from that data, from that experience, right, it starts behaving like a human. That is a machine learning in a very, a layman's term. And guys, if you are using, a specific computer, architecture to process the data, that computer architecture is known as, a neural network, guys, right? So neural network is a data processing kind of, architecture. So in neural network, we understand that how the data is being processed. So that is their neural network. And if in machine learning you are using neural network, then it is called as deep learning. So deep learning is not separate from machine learning, guys. First of all, you have to, make a clarity around that. And let me show you one image if I have. Just a minute. So just a minute, I just shared that. So guys, you can, see this. You can see this, that this is the image, right? And now here you see, this is the field of artificial intelligence. And to achieve AI, right? To achieve AI, what you can do, you can use machine learning. And within the machine learning, if you are using neural network, right? Within the machine learning, if you are using a neural network, then it is called as deep learning, right? It is called as deep learning. So guys, don't mix, AI uh, with, machine learning and deep learning, right? AI, to achieve AI, you can use, uh, ML or DL. That is there, right? You can use ML and DL. Now, just a minute, hold on, guys. Uh, Let me set up something. So guys, power is back, and just give me 2 minutes. I'll set up things, and we'll start. So just hold on, guys, for 2 minutes. Okay, guys, I'm back. Uh, can you please confirm if you can hear me because I switched my network from personal data to Wi-Fi, phone Wi-Fi. Okay, that's good. So, and now, guys, all of the training material, all of the instructions and the training material for this deep learning course are available on Google Drive, guys. And I'm sharing the Google Drive link again to you. This is the Google Drive link. So, that is there, right? That is there. And now again, let me start. So, okay, guys, now get settled. I think I'm in good position now. And thank you for your patience. Thank you for the wait, guys. And I'm sorry I kept you waiting for that. Uh, now, guys, let me start my sketch. So here is a sketch as well. Okay. So this is our deep learning class. Okay. A little repetition for the people. Now, guys, I gave you this, a definition of AI, that any machine which behaves like human is AI machine, and how you can achieve AI. That AI we can achieve through machine learning, or we can achieve through deep learning. And basically, deep learning is subset of ML only, right? And what we do in deep learning, guys, we do the computation using neural networks, using neural networks. And now let me quickly give you a informal definition of machine learning. What the machine learning is, what is ML. And I gave this example in my last class to the people as well. See, guys, let's see what is happening. There is a classroom, right? There is a classroom. There is a teacher. So this is the board here. People are sitting. So, people are sitting here and they are taking the class. And this is the exit. Okay. And now, let's say, we want to instruct this guy to take an exit, right? So this is the guy. Let's say we mark it as 1. So he wants to take an exit, right? And considering he has no idea to take exit, so we need to program him, right? We need to program him. And now point comes how we can program him. So basically, considering this guy as a CPU, maybe we can pass on couple of instructions, and those instructions will be followed by the CPU or this person, and following those instructions he can take a exit. So what kind of program we can write so that this guy as a CPU for us can take a exit? So we can have a couple of instructions, right? And step by step we can pass on these instructions to this person, and accordingly he can take the exit by executing the statements given to him. So what we can do as a first statement, so maybe we can pass on like stand up. That is the first instruction that goes to this CPU, which is this person, right? And then maybe after stand up we can say move right, for example, move right. And then we say move right, take some steps, right? Take steps X, for example. So he moves right, takes some steps. So this is this is there. Now we say move, or a move left in that case. So he takes a left move, and then we say take a step, take a steps Y. So he takes Y steps there and he reaches there, and then we say a move right, and then finally we give the instruction, a take exit. This is the case of explicitly programming your system, right? This is the case for explicitly programming the system, and this is not machine learning. This is not machine learning, right? Here we are explicitly giving the instructions, right, to CPU, to the person who is following those instructions. This is not machine learning. Then what happens in case of machine learning? In case of machine learning, guys, in case of machine learning, again, we have this room set up, right? And people are sitting here like this. And now this person one has to take exit. And in case of machine learning, guys, what happens? This person, right, sees how this this guy is taking exit. So how he's following and taking the exit. Then he looks at this person also, how he's taking the exit or she's taking exit, and how this is taking the exit, how takes the exit, or this takes the exit. So basically during the observation process, what is happening, guys? This machine is collecting the data. This machine is getting the experience, and based on that experience, based on those observations, based on the on that data, right, now it draws its own path without being explicitly programmed. This is machine learning. Here, guys, whatever was given to this machine one, it was all data, it was all experience, it was all how other people are taking the exit, and based on that experience, right, based on that experience, it took the exit. This is machine learning. Can you please confirm, guys, did you get it, or should I repeat it? Ashwarya saying yes. Okay. Meghna Jangir saying okay. Kushi saying repeat. Okay. Okay. That's good. Okay. So I'll do it one more time, guys. I'll just explain it one more time, right? See, guys, in this example, right? In this example, what I told you. In this example, we have a classroom setup, right? And in this case, guys, what we want, that these are people sitting here, and we can consider them as a computer machines, and they will follow what the instructions we give to them. And the instructions can be given to these machines using any programming language. You have written programs in C code, a CPU follows those instructions. You have written code in Java, you have written code in Python, you have written code in any other programming language. Your CPU follows those instructions, what you write in the source file, right? This is not ML case, right? We just gave explicit instructions to this machine that how, it has to take exit, like how it has to first stand up first, then take right, then take some steps, then move left, then take some steps, then move right, and then take exit. This is explicit programming, and that is what we do most of the time, right? That is how you develop projects most of the time, right? This is how you write some piece of code, let's to add two numbers, or to find the length of a string, to concatenate two strings, right? Or so this is kind of a rule set we have given. So this is set of rules we have given, and it follows those rule set and takes the exit. This is not machine learning. In case of machine learning, what happens, guys, we do not explicitly program, right? We do not explicitly program. What happens in case of machine learning, guys? This machine which wants to take exit, right? So let's say this is the machine which wants to take exit, and it wants to follow the machine learning way to take exit. Then what it sees that how other people are taking exit. So let's say this machine or this person takes an exit like this, So this is the one experience, right? This is the experience one for this machine. Okay, this guy takes exit this way, right? So this is experience two for this machine. So this is how data is being, feed to, so this is, one observation. This is called observation one, for example, right? This is another observation, right? Then, this person takes exit this way. This person takes exit this way. There can be different routes and different ways, or maybe this person takes the exits, this way. So all of these are experiences to our machine, right? All of these are experiences, observations, and this experience or observation, right? When we compile this experience, when we store this experience somewhere, this becomes data for us. This becomes data for us. So now, guys, this data is being fed to this machine, right? And when we feed this data to this machine, it finally draws the path without programmed explicitly, right? Without explicitly programmed, based on the data only. Now it will identify the right path for, and it can be anything, right? It can be this as well, it can be this as well, it can be this as well. It is just based on the data what path it identifies. This is machine learning. Guys, can you now confirm that did you get it now or not? Okay, that's cool. Okay, now quickly, let me, give you a formal definition of a machine learning for you guys. So maybe there are okay. So let me give me a let me take a poll, guys. Let me take a poll. I want to take a poll, and please use yes and no button only, right? Don't write in the chat. Don't raise your hand. Just say yes and no, and listen the question first, right? Listen the question first, right? What the question is: how many people in this room are joining for the first time any course from Forsk, right? The people who are joining for the first time, how many people are there? जिन्होंने पहले कभी भी Forsk का कोर्स नहीं लिया है, they are completely new to this, right? Please use yes or no. Please use yes or no button. Okay, okay. So still majority people are those people who have already taken some course, and but still a considerable number of people are there, okay, who are the first timers there. Okay, thank you guys, thank you. Okay, now one more question for you guys, one more question, please hold on. How many of you, right, have experience on Python programming? How many of you have experience on Python programming? Okay, okay, okay. So I think close to 85% people, they are, maybe you may be beginner, right? You may be at intermediate level, or maybe advanced, but Python. That was my question to you. Okay, that's good. Now, next question coming up, guys. Next question coming up for you. Please respond for that as well. How many of you guys, how many of you are aware of what machine learning is? How many of you are already aware what the machine learning is? Okay. Okay, fine. Okay, okay. So this time, a lot of people saying yep, but still, at the same time, a lot of people saying no as well, right? So, yeah. Okay. So Siddhant, you can just use yes and no button on the Zoom screen. That's it. That's the poll, Siddhant. Okay, cool guys. Thank you for that. So now, after understanding this, that to achieve AI, you can use machine learning, you can use deep learning. Now, guys, I will talk about what ML is, right? What is machine learning? What machine learning is. So please all focus, right? In mathematics, guys, we have this equation y is equal to fx, right? Where we call x as an independent variable. We call this as an independent variable, right? And the y is called as dependent variable. This is dependent variable. This y sometimes called as response as well. We call this as response as well, and we call target as well. So sometimes literature may use different names as well, but most of the time it is dependent variable, independent variable, and sometimes called as an input a variable as well, but not used much. People call it as independent variable on. This is there. Now guys, this f is called mapping function. This is called as mapping function. So basically this mapping function shows you the relationship between the independent variable and the dependent variable. For example, right, y is equal to mx plus c. This is a one relationship, one mapping function, which shows you that how x and y are related to each other. Maybe y is equal to a x to the power 3 plus bx to the power 2, or cx or d kind of. This is also a relationship. This is also a mapping function. It can be anything, right? Y is equal to for example, this can also be one of the mapping function. So this is all is there, right? This is all there. Now guys, in case of, right, in case of mathematics, what we are given x and we are given mapping function. And what is our responsibility and what is our job? That we need to identify what the y is. And obviously this is possible because in this relationship there are three entities, and if you know any two entities, you can figure out what was the third entity, right? So if you have x, if you have a mapping function, you can easily find out what the dependent variable is, or what the output is, or what the response, or a target value is. But in case of machine learning, guys, but in case of machine learning, what happens in case of machine learning? So that was mathematics, guys, and now we are moving to ML world, right? In case of machine learning, what is given to us, guys? X and Y is given to us. That means independent variable, dependent variable, these two are given. And if these two are given, obviously we can find out the mapping function, right? We can find out the mapping function. Guys, finding out the mapping function is known as training in machine learning. We call this activity of finding out the mapping function, f, right? Given x and y, this is called as training. And this x and y is called as data set, guys. This x and y is called as data set, where x is called feature. What you call x, guys? This independent variable is now called as feature or features, and y is called as label. This is called as label, guys. So x is called features, x, which was independent variable earlier in mathematics definition. In machine learning domain, we call this features, and y, which was dependent variable earlier, is now called as label. So you are given data set. In the data set, you will have features, you will have label. When both of these are given, you can find out the mapping function, right? Obviously, you need to use certain methods. Obviously, you need to use certain methods and ways that will identify the mapping function for you, right? So obviously, you use a lot of algorithms in machine learning
And what is their responsibility, guys? Their responsibility is to identify the mapping function, right? And finding out the mapping function is known as training, right, guys? This is known as training. And the algorithm that is being used to find out the mapping function is sometimes called as model, right? This is called as model. So we train the model, and while training the model, we identify this mapping function. And once the mapping function is known to us, what we can use? We can use that mapping function to find out the value of y for new x, the x which was not known to us so far. Now we have a new value of x. Now we have a new input data, and we can use that input data and feed that input data to our mapping function, and now it will give us the value of y, value of output, right? This act where we are using this mapping function to find out the value of y for a new x, this is known as prediction. This is called as prediction. So I think now you should have a clarity that what we are talking about. In a machine learning pipeline, guys, in a machine learning pipeline or in a machine learning project, what happens? You collect the data. So obviously data is collected. Maybe that data collection can be manual, or maybe you already have the data from some other third party, or maybe you have the data over internet. Maybe your data is stored in database, maybe your data is stored in Excel sheet, maybe your data is stored in a CSV file. It can be in any format, or maybe the data is in video format, maybe the data is in image format, maybe the data is in text format. So data collection is there. Once we have the data collection, guys, we have to do a lot of activities where we are talking about that how come we can clean this data, right? So data cleaning is there. So how come we can clean this data? Because data may not be in that format that can be directly used to train the model, that can be directly used to find out the mapping function. And for that, guys, you have to do some kind of pre-processing. That pre-processing is called as data cleaning. So we call this as a pre-processing as well, right? And sometimes people call this as feature engineering, guys. We call as a feature engineering as well. So there are a lot of terms. There is a new term called ETL as well: extract, transform, and load. So there are a lot of activities. So you have the data. It's a kind of like खेत में गए, वहां पे सब्जियां लेके तो आ गए, उखाड़ के तो ले गए, लेकिन उनको धोना भी पड़ेगा बनाने से पहले, राइट? उनको साफ भी करना पड़ेगा, राइट? और उनको चॉप भी करना पड़ेगा. So you have to do those preparations before you can make a curry out of that, right? So that is happening. The data, with the data as well, the real data would always be a dirty data, will always be a data which has a lot of noise, will always be a data which has a lot of irrelevant information. So we need to clean it up, we need to process it, we have to perform feature engineering. That happens there. Once your data has been cleaned, so now we have a cleaned data, guys, right? We have a cleaned data now. Right? Now we have the clean data. Now from this clean data, what you need to identify, guys, you need to figure out what is the feature and what the label is. And once you have features and label, that means you have independent variable, that means you have dependent variable, that means it was your X, that means it was your Y. So now you have features and label. And now using these features and label, what you can do, guys, you can model, you can train your model, right? You can train your model so that you can find out the mapping function, you can find out the relationship, right? You can find out that mathematical relationship. And once that mapping function is known to you, you can use that for performing the prediction on this data. So this is how the pipeline goes on, right? This is how pipeline goes on. You have data collection, then you have some data cleaning, pre-processing, feature engineering part. Then you figure out what the features and labels you have. Then you use some algorithm so that you can train the model. That means you can find out the mapping function. And once the mapping function is given to you, you can perform the prediction on the new set of features, on the new set of X values, on the new X. So guys, is that clear? Is machine learning process clear to everyone? Please let me know. Okay, so now a lot of people are saying yes. Okay, that's good. Okay, thank you. Now, after this, guys, we primarily divide machine learning into two subtypes. One is known as supervised machine learning, and other one is known as unsupervised machine learning. Guys, you have unsupervised machine learning, right? In case of supervised machine learning, please mind it, in case of supervised machine learning, the data set that you get, right, that data set will have features as well as label, right? It will have both. The data set which has features and label both is called as labeled data set. That is called as labeled data set. That data set is called as label. So if the data has label, if the data has value of y, then it is called as labeled data set. In case of unsupervised machine learning, guys, right, the data set only has features, only features. There is no label, right? There is no label, guys, in the data. That kind of data set is called as unlabeled data set. Unlabeled data set. That is called as unlabeled data set. And now you can easily understand from previous concept, guys, that if you have features and label both, then you can only perform to find out the mapping function, and then you can perform the prediction on the data, right? But that will not happen in case of unsupervised machine learning. Why it will not happen? Because your data only has features, and now you have no label. Because you have no label, you cannot find out the mapping function. That is not possible now, right? Because given y is equal to fx equation, you need to know at least two entities, right? Then only you can figure out what is the third entity. And this time we only have the features. We have no label. That means we cannot perform prediction in case of unsupervised machine learning, guys, right? And now, in case of supervised machine learning, again, we have two types. One is known as regression. One is known as regression, and other one is known as classification. Other one is known as classification. In case of regression, guys, if it is a regression problem under supervised machine learning, in case of regression problem, we are asked to predict some value, right? The problem will say that you need to predict salary. Problem may be like this, you need to predict height. Problem may be like this, you need to predict the BMI index. Problem is like that, you need to predict, the kind of, for example, box office, a collection on certain day for a movie release, right? So all of these cases are cases where you are, you need to predict a number, you need to predict a value, you need to predict a number. So that is a regression problem. In case of classification problem, guys, you will be asked to predict, right? You will need to predict a class, you need to predict a category, you need to predict a category. That means you don't predict the number, you predict a category, maybe pass or fail. That is one way of classification. Maybe say movie hit or movie flop. Again, that is a classification problem, right? Maybe on time arrival, right? Or delayed arrival. Again, that's a kind of a class. High or low, that is again a class, right? Finding or predicting whether the image is of an apple or orange, right? Whether the image is of cat or dog. In all these cases, right? So in all these cases, it is a classification problem. So guys, mind it, what is the difference between classification and regression? They both are part of the supervised machine learning, but in case of classification, you predict a category, you predict a class. Whether you will get a placement or not, it is a classification problem, right? Whether you will, you will succeed in exam or not. It's a classification problem, right? But what would be your salary, monthly salary after the placement? It's a regression problem, guys, right? How much you will score in the exam? It's a regression problem, right? So that is the difference between regression and classification. In regression, guys, there are again a lot of algorithms. I told you guys that you need to use some algorithm, you need to use some method so that you can identify the mapping function, right? And after identifying the mapping function, you can perform the prediction. Similarly, things are similar things are happening here as well. That for regression, you can have a lot of algorithms. So one is known as linear regression. That is there. You can use decision tree, random forest. These are the algorithms. These are the algorithms. Random forest, right? So these are the algorithms, decision tree and random forest. Similarly, for classification, guys, you have logistic regression. You have logistic regression. You have KNN, which is called as K nearest neighbor. You have SVM, which is called as support vector machine. You have naive Bayes, uh, as well, right? So there are a lot of algorithms. Even decision tree and random forest is also used here. Decision tree is used for classification as well, and random forest is also used for classification as well. So guys, don't get confused. Decision tree and random forest are the two algorithms which can be used for regression as well, and which can be used for classification as well, right? And now, guys, from this understanding, from this learning, now we need to make a shift from our focus, right? And what is the shift in focus? Let me explain that, right? So SVM is for classification, Prajesh. So now, guys, right? Now, guys, what is, there for you? Sometimes, sometimes, guys, what will happen? Your data set, right, has lot of images. So you have image data, right? Or your data has lot of videos. So it's a videos data, right? Or your data has lot of text, right? So again, this is a large volume of data, large volume of data. And guys, when you have a large volume of data, our machine learning that we have learned so far, right, is not fit, or it is not the right candidate that you can use to solve such problems which involve image data, video data, or text data. For that, you need to have a different approach. And if you are dealing with such data which has images or videos or text or audio as well, right? Audio as well. For that kind of data processing, you need to use neural networks, guys. You need to use neural networks. And when you use neural networks, that is called as deep learning, guys. And now you need to understand a couple of concepts that, let me, give you a graph. Here is a graph, guys, a very important one. What the graph is? On the x-axis, guys, I'm talking about data size or data volume, right? Data volume. And this is the performance of our machine learning model. This is our performance of machine learning model, right? And now, guys, see this, what happens. This is a graph which is, denoting a machine learning approach. And guys, this is the graph which is denoting a deep learning approach. So guys, this is the graph for machine learning, right? And this is the graph for a deep learning. guys, and this is a kind of a threshold, right? This is a kind of a threshold, guys. After looking at this, a graph or looking at this image, can you suggest me that if your data set is less in volume, right? Your data set is less in volume, then what you should use, whether you should ML or whether you should deep learning? What is your understanding, guys? From this data, right, you can clearly understand, and a lot of people are responding to that, and thanks for that understanding, guys. Yes, right? You can see that if your data set is small, your machine learning model has better performance than your deep learning. It doesn't mean that you cannot have deep learning here. You still can have a deep learning here while your data set is small, but that will not have a very good performance as compared to a machine learning model, right? But as your data set becomes large in volume, and that's where you talk about video data, image data, text data, and audio data, there you will see our machine learning algorithms are not performing well. They have got some kind of a saturation that even in the increase of data, right, there is no increase in the performance of the machine learning model. But at the same time, you can see that the deep learning a model is performing very well. So you are having more data, better the performance of deep learning model is, better the performance of deep learning model. And that's why, guys, you have to understand both concept. It's not like that you should focus only on the deep learning because it's fancy nowadays. It solves computer vision problems. It solves your text data problems. It solves your audio data problems. No, right? Every client, every company is not working on that. Still, there are lots of clients in the industry who are working on a small data set, and there you still need to use ML rather than deep learning. You still need to use machine learning rather than deep learning. So it depends what use case you are handling, and accordingly you will have to choose whether you should use machine learning or whether you should use a deep learning for that, right? So that was my justification, that where you should take a call, right? Where in you should take a call that what you should use. You should use deep learning or you should use machine learning. Now, guys, in terms of tool and technology, let me come on that part as well. So let's say this is ML, and guys, this is our DL, right? In machine learning, you are using Python, right? People use R as well. People use SAS as well. There are tools, obviously, but Python is the most used. In deep learning, people use Python as well, right? And people use R as well, but obviously Python is there, right, as the most popular one. And then, guys, you use a libraries called pandas. You use NumPy. You use uh, a matplotlib in this area, right? So here as well, guys, right? Here as well, you may need to use pandas, you may need to use NumPy, and you may need to use matplotlib as well. So both of the places, whether it's a machine learning a problem, it's a deep learning problem, you will need these libraries, guys. These are everywhere. They are in the ML as well, and they are in the deep learning as well, right? Now, what I was talking about, algorithms. What the algorithms are, they are used to find out the mapping function, right? They are used to find out the mapping function. That activity is called as training of the model, right? So the library which has all of the algorithms that you can use in any machine learning project, that library is called as sklearn. Sklearn, people call it as scikit-learn. So in a normal conversation, people will say it's scikit-learn, but in coding, we use this as a sklearn, right? Now, here guys, here we use different libraries. The library which is most popular here is known as Keras, which is from Google. It's an open source library, guys. So it is used, to handle deep learning projects. Then the other library that is there is known as TensorFlow. Again, this library is from Google. And guys, mind it, Keras uses lot of features from TensorFlow. That means for Keras, right? For Keras, behind the scene, it is using TensorFlow only. Did you get it, guys, what I'm telling you? Even if you're using Keras, that's okay. But Keras behind the scene will use TensorFlow. It will use a TensorFlow. Now, guys, TensorFlow 2 is available. New version of the TensorFlow has been launched. And now, guys, there is another library that is called as PyTorch. That library is from Facebook and Uber. Both teams worked on this and they developed this PyTorch. This is also again used for deep learning projects. We have other libraries as well, MXNet. It is used by Amazon. It's used by Microsoft as well. So, but as of now, the most popular libraries are Keras, TensorFlow, and PyTorch. Keras, TensorFlow, and PyTorch. So this is all about the technology stack, guys. This is all about the technology stack. And now, a couple of things for you. There can be a situation in the future, right? There can be a situation in the future which says that, what I was talking about, guys, mind it, and that's a very important kind of a announcement for you. You should focus on that. What I told you in the beginning around that, a machine learning cycle, I told you that data collection is there, right? Data collection is there. Once you collect the data, what is happening, guys? You need to, pre-process the data. So data pre-processing is there, right? Feature engineering is there. So all of these activities are like, data cleaning activities. So feature engineering is there. And then after that, guys, what you do, you figure out the features and labels in your data. And then what you do, guys, you deploy some algorithm, right, that find out the mapping function, and then you perform the predictions on this data, right? And during this algorithm finding only, you train the data and all, right? Training happens there. Now, guys, what is important? Google has recently, launched a platform that is known as AutoML. That is known as AutoML. And this AutoML is so powerful that it can automate this entire activity. Finding out the right algorithm, training that algorithm, finding out the mapping function, using that function to predict the data, and making sure that, yes, we are getting the correct and accurate results. If one algorithm is not giving the correct results, AutoML will have a different algorithm, right? So because to perform the same activity, you can have multiple ways, you can have multiple algorithms, right? So guys, entire activity is now automated using AutoML, right? This entire activity has been. And even there is a very good company based out of Chennai, if you heard about it, guys, S2O. They have also launched their platform which automates this process, right? Which automates this process. Which automates this process. So now, guys, this is entirely automated. You don't need to write any code for it, right? You don't need to write any code for it. then what is the utility of a data analyst, right? What is the utility of a data scientist? Then what is their utility? Will they lose their job? No, guys, right? This activity where you have the data, where you are performing pre-processing, where you're performing feature engineering, where you are cleaning the things, where you are identifying the features and label, all of this activity, right, there, is still a lot of scope, lot of jobs there, right? There are a lot of job opportunities here. There are a lot of job opportunities. Right. So it doesn't mean, right, that auto ML will, replace the data scientist or will replace the ML engineer. No, auto ML is, trying to solve one part, which is very much mechanical in nature. But this, guys, this keeps on changing with every project. In every project, you have a different data. In every project, you have a different pre-processing activities. In every project, you have different feature engineering, activities. In every project, you will have different features and different, right? So obviously, you need to understand this requirement, right? You need to understand this requirement, guys, right? And all of these activities, right, from here to here, right, starting from data collection to giving the visualization and, using visualizations and everything, all of these activities, they all come under a name called data science. This is all data sciences, right? This is all data sciences. So now, guys, you need to understand this S2 is also a very good company, and I think the best company which is working in India and is leader in data science and machine learning and AI. I think that company, which is Indian basically, right? I will not say Google, or I will not say Microsoft, or I will not say Facebook. They are all US company, but the company which is Indian by roots is Mu Sigma, right? That company is Mu Sigma. It's based out of Bangalore, right? And it's a very, very good company. I think to a fresher, they offer around a package of around 30 lakhs or, 40 lakhs, I think. That is their minimum package to start with for freshers. And don't be happy with that amount, guys. If you want to really fetch that, package, you really need to be good at, something what you are claiming in your resume, right? You really need to be good into that. And that comes through practice only, and that too, a lot of practice actually, right? So this is there now, guys. Those things are clear so far, guys. Please give me your feedback. Okay, people saying yes. Okay, cool, guys. So okay, so I will say, how is the juice, guys? How is the juice, huh? So hi, sir. Thank you. Okay, cool. So sometimes we do use sklearn as well, right, in deep learning, and sometimes that is used for some minor activities. It doesn't mean that you cannot use scikit-learn in deep learning projects. You can use a scikit-learn in deep learning projects, but in minor cases only, right? Your algorithms and training the model and having the predictions for that, you will be using Keras or TensorFlow or PyTorch only. Now, guys, coming to a next discussion, and that is very important actually. So let me have a sip of water first. Now, there's a question coming up, so let me answer that, guys. Guys, all of the sessions are recorded, right? So recording would be available on our YouTube channel and that YouTube channel is Forsk Coding School. Forsk Coding School. So please go to YouTube, and Dr. Sylvester, can you please share our YouTube channel link so people can go there and
Sure.
subscribe to it. So Redima, don't worry about it, right? So Viswajit, I will answer that question on day 3, right? When we talk about computer vision, I will answer that part as well, right? So as of now, please focus on what I say. And very important discussion. Now we are shifting the gears. So far, things were kind of a little repetitive for the users who already know machine learning, right? Yes, Savik, we can do that. There are different ways, but we can do that. So guys, let's understand what the neural network is. So now I will focus on neural networks, right? So I will focus on neural networks, right? So Akshay, the day-wise schedule is available on the Google Drive. There is an image available in the Google Drive, guys, and you can access that image. It has a day-wise plan what we are going to have every day. Okay. Please, everybody focus here. Everybody focus here what I'm talking about, what the neural networks are. So neural network is a kind of an architecture, right? It's a kind of a way, and we use this architecture to process the data. We use this architecture to process the data and use this architecture in deep learning as well. And now, guys, listen to me what I'm saying. Basically, a neural network is a layered architecture. It is a layered architecture. Listen, everybody, it's a layered architecture. What do you mean by layered architecture? So let me tell you what is the meaning of a layered architecture. So guys, in the layered architecture, we have various layers, and these layers actually process the data, right? So guys, this is our first layer, right? And what happens, this is my first layer, guys, this is my first layer. It will read the data. It will read our input data, right? So data input is from there. So this is how data input is there, guys. And now it will read the data and pass on this data to its next layer. So we have a next layer then, guys, right? Now, guys, this layer will also do some processing on this data, which is the output from the previous layer, and again giving this data to next layer, guys, right? And this layer again doing some processing on the data and giving this data in the output to the next layer. So it can have a many layers, guys, right? It can have many layers. And finally, guys, there is a last layer in our neural network. There is a last layer in our neural network which gives us the output, guys, right? Which gives us the output, which gives us the prediction, guys, right? So now please everybody listen to me first, then I will answer your questions. So guys, what I said, this is our first layer. And this first layer, or the leftmost layer in this diagram, is the layer which reads our data. The data is, read by this. So we feed our data here. This first layer, guys, this first layer is called as input layer. What do we call this, guys? We call this as a layer as an input layer. So input layer means the layer which reads the data that is there. Okay. And guys, this last layer, which is giving us the output, which is giving us the prediction, this layer is known as output layer. This known as output layer. And guys, all of other layers which are in between input layer and output layer, guys. All of those layers, these layers, right? This layer, this layer, this layer, all of these layers, they all are called hidden layer in the neural network. They all are called hidden layer in the neural network. So guys, I have 3 terms for you, or a couple of more in fact. What was those terms? So let me recap it. Neural network is a computation architecture in computer science world. It's a layered architecture, right? So Isika, please forget OSI model as of now, right? We'll look more into this and then you will understand more around that. So guys, OSI is also a layered architecture to process the data, but internals are different from OSI model, right? So guys, it's a layered architecture. And how come layers are connected to each other? So on the left-hand side, the leftmost layer is called the input layer, which reads the data. Then the output of this layer goes to next layer. Next layer also does some processing. The output of that layer goes to next layer, so on, so on. So it is basically the data propagates, from one layer to next layer, and so output of a previous layer works as an input to the next layer, right? Output of the previous layer works as an input to the next layer, and this is how they are. The rightmost layer, which gives you the prediction or output, is called output layer, and the layers in between, all of them are called hidden layers, right? If more the hidden layers, guys, more the hidden layers, right, more deep the network is, more deep the model is that is there. And sometimes, in some of the cases, number of hidden layers can be 50, number of hidden layers can be 100. The number of hidden layers basically decides the complexity of our model. If you have more number of hidden layers, your model would be more complex. If you have lesser number of hidden layers, your model would be a simple model. So guys, is this architecture clear to you, what I was talking about? Neural networks, it's a layered architecture. 3 terms here: input layer, output layer, and hidden layer. Clear? Bataएं please confirm everybody. Okay, cool. Now let's go a little closer to any layer now, right? Let's go to a little closer, and we need to zoom in to any layer now. Let's go inside the layer, any layer, right? So understand that part now, guys. What is there inside a layer, right? So guys, every layer has some processing units inside it. Every layer. So let's say this is layer, and in this diagram I'm depicting that it has got 3 processing unit. These are the elementary units. These are the units, and we call these units basically as node. What we call them, guys? We call them as node. So guys, this layer in the screen that you see, it has got 3 nodes into that, right? So every layer inside it will have a set of nodes into that. So it will have a nodes inside it. And now guys, let's focus on a single node. So we zoomed in on the layer, we went into the layer, and there we saw a lot of nodes. Now we want to see the details of a particular node. So guys, any node would be like this. So this is my node, guys. This is my node. This node has input. Guys, mind it. This node has an input. This node has an output as well. Okay. And other than input and output, guys, this node has a weight. It's a numerical number. We call, this is a numeric number. Most of the time it is a floating number, weight. And it has another property as well. This is called as bias. And along with this, guys, it has a mapping function, and that mapping function is called as activation function. Activation function. And now, guys, don't be in hurry to learn everything today. You will mess up, right? You will not get anything if you are running fast ahead of me. Please understand that carefully. I have entire 1 week, and I will completely devote that week for you and you only, guys, to make you understand what the deep learning is. And I really mean it, right? So please listen to me first. So guys, there is a node, right? There is a node. And now, guys, this node has a couple of properties. And I told you guys, neural network is used in deep learning. In every deep learning project, it is neural network. Deep learning cannot happen without neural network. That's it. Now, guys, I told you that every node, so let me repeat it again, every node will have a input. So this is input. Every node will have an output as well. And then every node will have a weight. That's a number, basically. And every node will have a bias. And every node will have an activation function as well. Activation function. How come all these are related to each other? So guys, output is always equal to, guys, mind it, output is always and always equal to input multiplied with weight and adding bias to this, and finally passing this value to activation function. So guys, AF stands for activation function. So this is the relationship, guys. This is the relationship, that output is equal to input multiplied with weight, right? And adding bias to it. And, this is an activation function. So now listen to me, guys. This mathematical equation mx plus c, right? And what does it mean? Here this m is called as slope, or this m is sometimes called as coefficient as well, right? This c is called intercept or constant, guys. In machine learning, this c indicates the bias. This is the indicator of bias, guys. This is the indicator of bias. I'll explain that part too as well, right? And this is obviously the output. So guys, here you can see x is input, right? So here x is input. What is weight here? This is m. And what is bias here? This is c. That's there, right? Now, guys, listen to me. So will you remember, guys, these 4 or 5 terms for every node? I will explain the activation functions little later, guys, right? I will explain the activation functions a little later, but don't worry. As of now, activation function, that means it's a function which will do something, right, on the input and will give us the output. Now, guys, output is always equal to input multiplied with weight bias added to it, right? And this, passed to the activation function. This is how the relationship is there, right? Savik, no. We'll let you know later, but not what you say, right? Yeah. Now, guys, what the bias is, let me explain this to you, right? Let's say, guys, we have, two lines. They are parallel to each other, right? If they are parallel to each other, that means they have same slope, right? They have same angle. Let's say that angle is 45 degrees, so m is 1. The slope is 1 here. And now, guys, we have this x, and let's say this x is certain value. And now, guys, we see what would be the output, right, given by this straight line which passing through the horizon. Can you see, guys? We go there, go there, go there, and we cut it here. And this is, the output, right? So let's say this comes out to be y1. And for this line, guys, what will happen? We go there, go there, go there, and cut it here, right? And this would be the output, that is y2. And now, guys, lines have the same slope, right? Lines have the same slope, right? But y2 and y1 are different just because this line, right? In this line, guys, this c is different, right? Here for this line, c is equal to 0, and for this line, c is not equal to 0. Some values there. Let's say c is equal to 2. So, guys, if we calculate, for this, right? Let's say x is 2. For this line, guys, y1 would be equal to mx plus c, where m is 1, x is 2, c is 0, so y1 is equal to 2 for this line, right? But for this line, guys, what would be the case? Y2 would be equal to mx plus c again, where m is 1, x is 2, but c is 2, right? So, guys, can you see this portion and this portion are same, but because of the bias, we got a different output, right? This is called as biased, right? A kind of a pre-added, stuff, a kind of a pre-added stuff. So let's say there is a wall, right? So there is a wall, and there is something, a chocolate box is there. This chocolate box is, put it here, right? And now there is a kid, right, who want to get access to these chocolate, who want to eat those a chocolate. So what it does, he comes nearby the wall and raises the hand as well, but he's not able to reach, right? And now what he does, he looks for a stool somewhere, right? So now he comes with a stool. So he has a stool now. He stands on that, right? And now able to reach out to chocolates. So basically this stool has given some predefined height to this kid, right? This is bias. This is bias. And this will work for everybody, right? Whether I'm, a taller or whether I'm, short, it doesn't matter. If I'm using that stool, right, it is always, giving me some advantage, right, to me in terms of getting the chocolates. Now, did you get the idea of bias, guys? Did you get the idea of bias, what the bias is? Now, guys, listen. Yes, Pradeep, you are right. Right? No, it exists everywhere, Isika. But for explanation purpose, we are using 2D plane. But it will exist everywhere, right? Now, guys, couple of more things for you, right? Couple of more things, and understand them as well. See, after understanding this concept that, we have a hidden, we have an input layer, we have a hidden layer, for example, for simplicity, and we have an output layer. So 3 layers are there. Just for explanation purpose, I'm using just one hidden layer. So this is input layer, right? This is my hidden layer, and this is my output layer. And let's say this input layer has 3 nodes, right? And this hidden layer has 2 nodes. And let's say this output layer has 1 node only, for example, right? And see what is happening here. Now, guys, this input layer will take a data. So one input is coming here, one input is coming here, and one input is coming here, right? And now, guys, what will happen? This is the node, right? Which has a weight, which has a bias. This is the node which has a weight. As of now, you can understand like that only, right? Just for a simplicity, I'm just giving, I'll explain more details later on. So it has a weight and bias. So now what happens, guys? The output of this node goes to this as well, and output of this node goes to this node as well, right? Similarly, output of this node will go to this node as well and this node as well. Output of this node will go to this node as well and this node as well. And similarly in the next layer as well, guys, output goes to this as well, and output from this node to goes. And then we have the final output here. And there you can see, guys, that every node, right? Every node in the previous layer is connected to, right? Every node in the next layer, right? Can you see this, guys? Every node in the, so I think that would be much better. Let me have this. Can you see, guys? This is the image we have. This is the image we have, right? So you can see here, input layer has 3 nodes in this example. Hidden layer has 4 nodes in the example, and output layer has 2 nodes in the example. And there you can see this node is connected to every other node in the next layer, right? And in this node, right, this node output is connected to every other node in the hidden layer. And this node is connected to every node in the next layer, right? So this is this. Nitika, we call this layer as a hidden layer, right? It's a kind of a layer which is not seen by the user. User can see, where to give the data as input. So input layer is known to user, and where to get the output. So output layer is also seen, but other things are not visible in terms of system uses, and that's why we call this as a hidden layer, right? So as of now, nothing hidden. I'm going to explain everything, there. So we are trying to explore everything, whether it's an input layer, whether it's a hidden layer, whether it's a output layer. All right. So guys, this kind of connection that you see in the image and, on the sketch as well, right? This is, known as, a dense network as well, guys. We call this as dense network as well. Why we are calling it as a dense number? We are calling this as a dense number because every node, right, is connected to all the nodes in the next layer. So this node is connected to every node in the next layer, right? So this is called as dense network or full connection, guys. We call this as a full connection or dense. So this is called as, this. Now question comes, guys. There are, things you have to understand. We'll take those questions one by one. So guys, do you understand the neural network philosophy a little bit now, right? That what the neural network is, what is their architecture, what is input layer, what is hidden layer, what is the output layer, and inside every layer we have set of nodes, and every node has an input, every node has a weight, every node has a a bias, every node has an activation function, and output is a related it is based on the input multiplied with weight, added bias to it, and passing that to activation function that is there, right? Now couple of questions, right? Couple of questions. So guys, hidden layer is basically, if you understand, right, hidden layer is a kind of intermediate data processing, right? It's a kind of intermediate data processing. And the data that is being given by the input layer to the next layer. So here some intermediate processings are happening. So we'll understand more on that. Now guys, a couple of other discussions, right? So so node is a processing unit, Pradeep. Node is a processing unit. That's it, right? And a processing unit which takes some unit, input, gives the output, and it has some weight and it has some bias and it has activation function. So that is there. And it is not feature, Pradeep. That is not feature. Now guys, listen. Now a couple of questions for us, right? No, Sujit. We are discussing all about neural networks, all, and obviously they are used in deep learning. And now guys, question comes to us. How many nodes in input layer? That is my first question. How many nodes in input layer, right? How many nodes in the input layer? Let me explain to you, right? Guys, number of nodes, right? Guys, listen to me. Number of nodes, guys, depends on the data. Listen to me, guys. Number of nodes, right? Number of nodes depends on the data set. The data that you are trying to solve, the data that you are trying to handle. Okay? So how is that? So guys, number of nodes in the input layer would be always equal to number of features in the data. Guys, number of features in the data, right? So let's say your data has one feature only, then it will have only one node. If your data has two features, right, it will have two nodes. If your data has three features, it will have three nodes. So number of features decides the number of nodes in the input layer. Is that clear, guys? That number of, because that reason is very simple, guys. Let's say we have a data, right? We have a data, and let me explain that data to you a little. I'll just take that part. See this, guys. Let's say, guys, we have a data set. There are, so there is a person A, right, who is, for example, BTech, and who has 2 years of experience, right, and has got 2 certificates, and this is the salary. Let's say this is the 40,000 salary, right? There's another person who is again BTech, who has got 5 years of experience, who has got 1 certificate, and let's say his salary is 50,000. There is one more guy who is, who is C, and has MTech, right, has got 3 years of experience. There is no certificate yet. And let's say the salary is 30,000, right? And then there is a one more guy who's D, who has done a BTech again, right? Has 10 years of experience, has got 5 certificates with him, and let's say the salary is 70K, for example, right? Now in this data set, guys, the name is one feature, the degree or the qualification is another feature, right? The experience is one feature, and this, the certificate count is one more feature. So these are the 4 features, and based on these features, what we have the salary. So that means salary is the label. So if we know the name of a guy and we know about his qualification, we know about his experience, we know about his certificate count, what we can do, guys, we can make a prediction about the salary. Can we do or not? If we are given, right? If we are given a name, we are given a qualification, yes, right? So if we know that, right, and we can calculate the salary. So guys, these are the 4 features. And now tell me, guys, if we have 4 features, how many nodes we will have in our input layer now? Now tell me, how many nodes we will require, guys? Now we will require 4 nodes. Why we are getting 4 nodes? Understand that part, guys. Now we have 4 nodes, this and this. Okay. Now, guys, see, to read the name, right, guys? To read the name for user, we have 1 node. So it will read the name. Okay. Education qualification, this node will read the education qualification. The experience, this node will read the experience, right? And the certificate count, this node. So that means to feed this entire record in one go, right? You need, a 4 nodes in your input layer. And sometimes what, guys, what happens? Generally, a name may not be a better, a judgmental or a better judge about the salary, right? Because name hardly affects the salary of a people. So sometimes what people do during the pre-processing or during the feature engineering, what they will do, they will drop this column, right? They will not use it, right? And in that case only, guys, what will happen? Now we are only left with 3 features, right? They will have only 3 features, and in that case, guys, how many nodes would be required if you drop the column? The 3 nodes would be required, guys. This, right? So Sujit, name is not label here. Salary is the label, right? Salary is the label. So we need to predict it. We have that label, right? So that is there. Okay, now question comes, guys, that now if we understand this concept that number of features decides the number of nodes in the input layer, what will happen if we have the data in image format? What will happen if we have a data, let's say we have a data which is in, image format, and guys, we have an image which is of, let's say, 20 by 20 pixels. हमारे पास एक image है, we have a one image 20 by 20 pixels, guys, right? And this 20 by 20 image, now we need to, give this image as an input data. Now, can you guys guess what would be the number of nodes in this case? What would be the number of nodes in this case, guys? Guys, listen, when you have image data, everybody listen, please listen to me. Guys, if you have image data, in case of image data, every pixel works as a single feature, guys. Every pixel works as a feature. So now tell me, guys, if this is an image of 20 by 20, how many pixels it will have, guys? it will have 400 pixels, right? How many pixels? Why it will have 400 pixels, guys? That's simple. That is a very simple equation, right? Because if we say that there is an image of 20 by 20, that means it has 20 rows, right? And 20 columns. And every cell is a a pixel. This is pixels, right? So this way we'll have 20 columns and this way we'll have 20 rows. So in total it will have 400 nodes. So guys, how many 400 pixels? So how many nodes we will need in our input layer, guys? We will need 400 nodes. Is that clear now, guys? So if your image has 1000 pixels, your input layer will have 1000 nodes. If your input image has 10,000 pixels, your input node will have 10,000 nodes. That's it. That is very simple. Right? Now, yeah, that number can be anything, Tala. Right. Now coming to a discussion, guys, coming to a discussion, how many nodes in the output layer? So I told you guys that how we decide. I told you guys how we decide how many layers, right? Shreyans, we need to define, right? How many nodes? Sorry, it was not layers, right? So how many nodes? How many nodes in output layer? I will answer one by one, guys. Don't worry. We will continue this discussion tomorrow as well, right? We will continue this discussion tomorrow as well. Don't worry about it. So how many nodes in output layer? Now, let's, give me an update on this. Guys, this is, if, guys, listen, everybody. If you are trying to perform a regression, understand my concept, guys. If your problem is a regression problem, right, that you need to predict a number, right? You need to predict a value. In that case, guys, a one node is enough. So one node is required, right? One node is enough in the output layer. Is that clear, everybody, guys? Because what you need to do in regression, you just need to give a number that would be the salary, that would be the height, that would be the weight, that would be blah blah blah. So you just need to predict a single value, and that can happen through a single node without any issue. That's there, guys. So in regression, we take only one node. Okay. This is about regression, guys. What if our problem is classification problem? In classification, guys, what we do? In classification, we predict a category, we predict a class, right? Yes or no, pass or fail, or let's say you need to predict that what is in the image, right? Whether it's a car, whether it's a truck, or whether it's a bike, right? Or what is that, right? So it can have more than two categories as well. The classification may have more than two categories as well. So guys, listen, in that case, in case of classification, guys, listen to me carefully. The number of nodes, right? Number of nodes is equal to number of classes, right? Number of classes or categories, right? If your data has only two classes, pass or fail, for example, that means how many nodes are required? in the output layer, guys? 2 nodes are required, right? If your data has, 5 classes, if your data has 5 classes, guys, in that case, you will need 5 labels. But hold on, guys. This is not end of the story about the output layer. Listen to me carefully, right? See, guys, what I gave you. Let's say we have 2 labels, high and low. And for understanding so far how many nodes we can use in the output layer, guys, we can use 2 nodes. So we can keep this node to indicate high, and we can keep this node to indicate low. So guys, when the output is like this, that this is giving 1 and this is giving 0, that means what is the class predicted by our node? The class predicted by us, by the model is a high, right? High. Why high? Because high node is 1 and the low node is 0. So that means what is the indication given by the output layer? The prediction is high. What will happen if this is 0 and this is 1? What will happen in this case, guys? What would be the prediction? In this case, prediction would be low, right? But hold on, guys. That is okay. Can I use just one single node, right? Can I use just one single node in this case, where I only have 2 categories? So this is the specific case of the 2 categories only. If you only have 2 categories or 2 classes, this is known as binary classification. You know, guys, what you call it? A binary classification. So I'm talking about binary classification only. That in case of binary classification, guys, what you can do, you can have only one node. Why? Because if this is 1, I will mark as prediction high, right? And if this is low, I will mark this prediction as low. So if this is 1, I will say high. If this is 0, I will say low. That means in case of binary classification, I can, manage my job by just having one node in the output layer. In the output layer. So guys, in case of binary classification, we only take one node in the output layer. Guys, give me feedback. Is that clear to you or not? Right? Yeah. Okay. Now coming to multi-class classification. Multi-class classification. In case of multi-class classification, guys, you have more than 2 categories or 2 classes. You have more than 2 categories or 2 classes. So let's say, guys, you have, 3 classes. One is for apple, one is for mango, and the other is for orange, right? No, Akash. Now, guys, in this case, because this is a multi-class classification, we have 3 classes, right? So now, guys, we will have 3 nodes. What is happening? See, listen, guys. This node is for apple, this node is for mango, and this node is for orange. Guys, what will happen? Let's say this is 1. This is 0, and this is also 0. What would be my class prediction, guys? Can someone let me know what class my model has predicted if this is 1 and rest are 0? What class has been predicted by it? This is for apple, right? This is apple. What will happen in the case, guys, if this is 0, this is 1, and this is 0 again? What will happen this, guys? This would be the class mango. What will happen if this is the case? This would be orange. Generally, guys, listen to me. Generally, these nodes do not give us directly 1 or 0. They do not give us directly high or low. What happens, guys, when we give an input image to them, Listen to me carefully, right? When we give an input image to them, the neural network will do some processing internally, right? And now in the final output layer, guys, this is output layer, right? In the output layer, this node will give a probability that I'm 80% sure that this is an apple. Okay, fine. It will say I'm 15% sure or I'm 15% confident this is going to be mango. And this node will say I'm 5% confident this is orange. So guys, can you see that every node gives us a probability? Every node gives us a confidence. And now what we do, guys, we rely on a node which is giving us the highest confidence. So what we do, guys, in this case, we make this 80% 1 and we make others as 0, right? And in some other case, if this node is saying that I'm 75% confident, this says I'm 25% confident, and this says I'm, how much would be that, guys? 85 and then negative, so 5% sure, right? In that case, guys, this node has got the highest, confidence, so we will say it is a mango. So guys, this is how it happens in a classification. So remember, guys, now I tell you to finally summarize, right? To finally summarize this. Ishika Singh sir, if equals, okay, generally that probability, if you talk about probability in terms of fraction, that can go up to a very, a longer calculation, right? And somewhere in that process, we decide which one is, a slightly higher than the other, exactly getting a probability, right? Like this 40.0000000000, and the other also giving 40.00000000. It is very difficult to have. Ishika, Vittal, right? So, somehow, we can, calculate that. Now, guys, let me quickly summarize what we did yesterday. Things may be very clear, before the start of the neural network, because that was more of a concept or a kind of a use case studies, right? But things got little complex after the arrival of a neural network, right? And now neural network would be discussed in every class now onwards, guys. We are going to, discuss, yeah, Ashish. We are always going to discuss the neural. And guys, my discussion on neural network is not finished yet, right? My discussion on neural networks is not finished yet. And now, let me, explain this, guys, again. I told you that neural network is a layered architecture, right? Neural network is a layered architecture. So we have layers, right? And now, guys, you start responding me. How many nodes I told you in the input layer, guys? How many nodes in the input layer I told you? That would be equal to number of features. That was very simple, right? How many number of nodes in the output layer, guys, I told you? I told you that if it is a regression, a single node is enough. If it is a binary classification, guys, again, one node is enough. If it is a multi-class classification, guys, then it has to be equal to number of classes or number of categories. That is there. Cool. I will discuss this part tomorrow, guys, that how many nodes in the hidden layer, right? Because this is hidden layer, right? I will discuss this part later on, but the number of nodes, right? Number of nodes in hidden layer, right? There is not a fixed number, right? Vittel, it can go with one only, You can keep two, but that, we can manage with one as well. So number of nodes in the hidden layer is, roughly equal to 2/3 of nodes in input layer, plus nodes in output layer. Guys, there is no fixed formula, there is no fixed number that you can give to number of nodes in the hidden layer, guys. Be very clear about it, right? So that is there. And also, number of nodes in the hidden layer can never be twice of nodes in input layer. Guys, these are the two conditions. So, and I told you this as well, right? So I told you guys that if you want to find out the number of nodes in the hidden layer, what formula you can use? You can have a rough number that would be equal to 2/3 of number of nodes in the input layer plus number of nodes in the output layer. ये तो number पता करने का है, but वो value कभी भी twice the number of nodes in the input layer से ज़्यादा नहीं होनी चाहिए. That value should never, be over and above the twice the number of nodes in the input layer. So that is kind of an upper value. That's a kind of a limit there. So guys, that was a introduction about neural network. And this architecture, guys, this architecture where we have, a nodes, and, every node has a connection like this, right? Has a connection like this, guys. And here, this, and then this. This is called as ANN. This is called as ANN. This is called as artificial neural network. इसी को हम ANN कहते हैं. Guys, this is called ANN, artificial neural network. That means ANN is the base of everything else in the deep learning. Whether you are using CNN, whether you are using RNN, or whether you are using, anything else, everything is based on ANN only. So guys, now I sign off for today's session. And now you need to tell me that, what is your feedback about today's session? Did you get it? Or, was it too heavy? Was it too light? Was it repetitive? What is, did you get it or not? That is more important. Forget about heavy or, light or, anything around that. The point is that you should understand that. So, right. If you have 16 classes, Shreyans, then you need to take 16 notes. That's it. And that will not happen what you are thinking that, each node can have high and low, and then you can just manage it through 8 nodes. No, Shreyans, not that way, right? So now a lot of people are saying that it was good, right? And Swati saying I got very well, Aishwarya saying understood easily the concept. I think if you have a good background in machine learning, then you can easily understand it. But if you're trying to directly jump to deep learning without, understanding the machine learning concepts, it would be a difficult for anyone, right? So yes, Vinay Govekar, you can do this. Vinay is saying, sir, I want to classify the location images into beach, forts, parks. Can I do that using CNN? Yes, you can do that very well, right? Ranjan Maharana saying, nice, sir, I got some knowledge about AI enamel, right? Pawar Bharat, आज एक दिन में ही सारी चीजें नहीं मिलेंगी, over, digest नहीं होगा, right? So just please hold on, have a patience. I will explain everything in time to come, right? Mr. P. Loganathan. Thank you for that, right? So guys, tomorrow we will, do, ANN implementation in practical, right? That would be there. And guys, today's project season will start at 9 p.m. Khana wana kha ke aaram se baithna, have your dinner, and then, sit on machine, right? And it will take around 1 hour. It would, go around 1 hour only. So, yeah, Nitin, you are right. You are right. Pawar, you have a lot of questions, and first to learn deep learning very clearly, you need to unlearn a lot of things. I think that is my understanding about you. You need to learn a lot of things. I think you have learned a lot many things from XYZ locations, and everything got jumbled. I may be wrong, and I wish I am wrong, but I think you need to unlearn first a lot of things. So, yeah, Sujit, you can do that. Right. Yeah, Devyarani, thank you. Ashwarya will come to know that about that, don't worry, right? Yes, Dalina, you are right. Node and neuron, they are same. Yes. Pawar, no need to download any tool, right? No need to, no. No, Tala, no one is going to take away your hardship, right? And that will happen later, Sashwant. We'll talk about that in the project season. So don't get mixed with that, right? Only one node is enough, Rohit, in binary classification, right? So you guys, we will not use Anaconda for deep learning. Guys, we will not use Anaconda for deep learning, right? Guys, we will not use Anaconda. We will use Google Colab. We will use Google Colab. It's a cloud-based tool which comes with GPU. So we will use Colab. I will explain what the Colab is in tomorrow's session, right? We will use Colab, Google Colab. It's a free tool, so no need to download. It's all online, right? Yeah, Rohit, you can do that as well. But the practice is that people use one for binary, right? The practice is like that. So this is there, guys. Okay, guys, see you tomorrow at 4 p.m. And, thank you, Pawar. Bharat Pawar, I think your name should be like that, right? Bharat Pawar. Yeah, okay. Yeah, thank you, Bharat. Thank you, guys. Bye-bye. Take care. See you tomorrow, 4 p.m. for the class. And see you again today at 9 p.m. If you are joining the project season, right? Yeah, Ishika will talk about that tomorrow. Don't worry, right? Bharat tomorrow, not today.